Hey class, this is a solution for problem number 9. In this case, we've got a box that we're going to make out of a sheet of tin. We're going to notch out some corners, and those corners are going to be 3 centimeters square pieces that we cut out. So we start out with an X by X sheet. I just don't know the dimensions, so I labeled them variables. And then we're going to work from there. I know that the finished box is going to hold 80 cubic centimeters. So let's try and use that information. The first thing that I note is that if I cut out these 3 centimeter pieces, then the leftover dimension is going to be x minus 6. And I can take that and say, okay, well, if this is x minus 6, then this other dimension along the base of this shape is going to be x minus 6. And I'll get a box like this. I know that volume is length times width times height, so the volume of this particular box that I'm building is going to be the quantity x minus 6 multiplied by the quantity x minus 6 times 3. I can expand that expression a little bit and wind up with the quantity x squared minus 12x plus 36. And we need to multiply all of that by 3. So that turns into 3x squared minus 36 plus 108. Just note that all 3 of these expressions are the same. They all represent the volume of the box. And x represents the square dimensions of the original sheet. So if the volume of the box is 80 centimeters cubed, then I can write in a quadratic equation like this. And I can find a value that makes that quadratic equation true. So in this case, notice that I just subtracted 80 from both sides of the blue quadratic equation, and then I get an equivalent quadratic equation. At this point, I've got it set up, and I can use the quadratic formula. Note here that the discriminant is 960 for this particular quadratic equation. Also, 960 is really close to a perfect square. 31 squared is 961. So not quite going to be a factorable quadratic expression, at least not nicely factorable. These two solutions those are both 0.3 is not a physically possible solution in this case, because the dimensions of the box, the square could be 0.03 multiplied by 0.03, and the dimensions of the box would be negative. So I know that the dimensions of the sheet that I started with are 11.16 centimeters by 11.16 centimeters. Hope that solution helps you out, and I'll see you in class.